20th May GFG question. So we are given a binary tree, and they're saying that this binary tree is catching a fire at a particular node. That target will also be given. So suppose it catches fire at node 2. At 1 unit of time, this fire will spread to its neighbor nodes. For example, at time 0, this node 2 catches fire. At time 1, this node 4, 5 as well as 1 will be on fire. At time 2, this node 3 will be on fire because it is neighbor of 1. There are no neighbors of 4 and 5 that are not burning, right? So this will stop propagation here. So now at time 2, 3 catches fire, and at time 3, nodes 6 and 7 catches the fire. So basically we have to return a particular value of time at which all the node of the tree are burning, right? That is the problem. Even though it is marked as hard, it is pretty medium kind of question if you ask me. So basically what can we do? We have to do here breadth first search. Now what is that? For example, you are at 2. You have to traverse breadth wise, like in a graph. You have to traverse 4, 5 and 1 at the same time, at a particular time. For example, you stored this 2 in a queue. You have to traverse all the neighbors of this queue and push it back into the queue. So then you push back 4, 5 and 1. Then you have these 3 nodes at queue, and you increment the time by 1 in all these traversals, right? Then you have to traverse the neighbors of 4, 5 and 1 in a single unit of time. So for example, you're traversing the neighbors of 4 and you encounter 2, but 2 is already visited, so you do not push back into the queue, because otherwise your queue will catch an infinity loop. So this 4 and 5 will push nothing, but this 1 will push back 3 in the queue, and now the queue has only 3. Now at time 2 we are again traversing 3, and we get the 6 and 7 as the neighbors, right? We do not push 1 back because it is already visited, so we also have to keep a track of a visited array here. But the only question is that how do you access? You can access the left child and right child of a node, but we cannot access parent of a node. So we have to manually create a map of all the nodes which contains their parent. For example, 2 points to 1. Why? Because the parent of 2 is 1. So we have to create an unordered map for this, and we can create an ordered map because it is mentioned in the question that all the nodes are unique. That is why we can set the node as the key in the unordered map. Otherwise we have to take some different approach. So first of all, we are going to do in-order traversal, simple in-order traversal. And in the in-order traversal, we have a condition. If it has left child, then we traverse for the left child, right? But along with that, we also going to do this. Our function will also have a map as an argument. So map of node of left is equals to node. So basically, we are assigning the left child, that is, let's suppose we are at 1. 1 has left child, so we are assigning the map of left child, that is map of 2 is equals to 1. So this will get assigned, and same thing we are going to do for the right child also. So after the execution of this in order traversal, we will get a map something like this. Now this map will not have one thing, that is the root element, because root has no parent, right? So it will consist all the nodes, all the other nodes, then root node. So let's check the approach. First is to create a map that stores the parent of each node, that we already did through the in-order traversal. Then we traverse the entire tree like a simple BFS. We just have to keep a track of a time variable, and we have to return the time. So let's look at how the BFS will work. Initially, this is our visited array. Initially, the queue has been inserted with 2. Why? Because 2 is given in the question, that is as the target, right? So let's again do this. So 2 is in the queue right now, right? This 2 is in the queue. Now, initially this is a visited array, and the value of time variable was initially -1. Why do we keep it at -1 and not 0? Because it is going to increment even in the last traversal. Like for example, the queue has 6 and 7, and it is traversing it, right? And in the end, it will also increment before getting out of the queue, before getting out of the loop. It will get out when the queue is empty. But right now the queue was traversing for 6, 7. But here, whenever the 6, 7 catches fire, we do not increment the count, right? Because there is nothing to, propagate the fire after 6 and 7. So it is incrementing one more time unnecessarily. That is why we are initializing it with -1 rather than 0. So in the first traversal, let's see, the queue has node 2, right? We check for 3 things: the left child, the right child, and the parent. So let's check for left child. If it has left child, we push it into the queue only if it is not visited. But right now all the nodes are not visited, then 2. So we pushed it into the queue. So our queue has now node 4, right? And whenever we start to traverse, we of course pop this 2 out. And then the node 2 has right child as 5, which is also not visited. So we push it into the queue also and mark it as visited. And this node has a parent 1, and that is also not visited, and that we push into the queue. So currently in the next time, and yes, our time variable will get incremented after all these pushes. Okay, so in the next traversal, our queue has N4, node 4, node 5, and node 1. And this is the current status of our visited variable, where 2 is visited, 1 is visited, 4 is visited, and 5 is visited. Okay. Next, same thing we are going to do for all these 3. Okay. So let's say just consider N4 right now. N4, does it have left child? No. It has right child? No. It has parent? Yes, but it is already visited. So we do not push it into the queue. Otherwise, we will keep, looping in the queue. Same thing for the 5, it does not have left child, right child, has parent, but it is already visited. And for 1, it has left child, already visited, it has no parent, and it has a right child, that is 3, and it is not visited. So we push 3 into the queue. So our queue now got only 3. But even if our queue gets 1 element, that means the nodes are left to catch fire. So at time 2, we incremented again this time 1, right? So at time 1, we have this status, we have queue with N3, we have this visited variable where we marked N3 as visited. Now we are traversing for 3. It has left child, yes, push it into the queue. It has right child, push it into the queue. The parent is already visited, skip it. So we have our queue with 6, 7. We have our time as 2. This is 2, not 3. This is 2. And we have our visited array with all true, because every node is visited. So this will traverse again, but this time our queue will not be able to find a single element to insert back into the queue, and then it will become empty. Our queue will become empty, but still here time got incremented. That is why we initialized with -1, right? So basically our loop will get a break because there is nothing in the queue, and we just have to return this time 3. We are given the value of the target, not the node location of the target, right? So if you want to push it into the queue initially, we have to find the actual node rather than just integer value. So that is why we are having a key variable here, and whenever we find it, we will store that location of target in the key. And we are also having the unordered map here. So simple unordered traversal, as I said, we are going to do in order traversal for root of left. We can also do it before assigning it to the map. We can do it after assigning to a map. It does not matter, right? So here the entire parent array, parent map will be generated through this in order function. And after that, we are also defining a visited array, a visited map, and initializing the time variable with -1. This is the queue. We are pushing the key, that is our target node, the location of our target, and then also marking it as visited. So while the queue is not empty, we're going to traverse for size, which means all the elements of the queue. For each element, we are going to do these things. First, we are going to pop out that element, then check for the left node. If it is not visited and it has a left node, then we mark it as visited and push it into the queue. If it has the right node and it is not visited, we again mark it as visited and push it into the queue. And similarly, if it has a parent, now this thing is very important to write map of node. Why? Because the root node will not have a parent. That is why it will give a segmentation error if you just write don't not visited in the map of parent, right? So we have to write map of node along with not visited map of node, and we do the similar thing, mark as visited and push it into the queue. And after all these entire while loop, inner while loop gets finished, we increment our unit of time, and in the end we just return the time variable. So it is pretty simple. Let's submit this. Right, so you will get this code in the GitHub link in the description. All right, thank you.